So in this video, we're doing question 3, November 2023 and 2024. So we're going to do them side by side. So we're looking at 311. So this is logarithm. So it would be good to look at the log rules first before looking at this part of the test. But if you can do question 1, 2, 3 and question 5, this would be enough just to make you pass. And anything more than this would be a bonus. So make sure you can answer question 1, 2, 3 and 5. Right, so in this first one of the log rules says that if it repeats, then it's equal to 1. So when the base follows the logarithm, it will give you an answer of 1. So this is what I'm talking about, right? So we're going to move that half to the front. Remember, all exponents. So when you have the answer value to the exponent, this means the exponent comes in front of the word log. So that's one of the rules. Whatever's an exponent, you can move it to the front. Okay, so we know that the answer is definitely going to be a half log a followed by a. Now remember that log to the base 5 is equal to 1. Okay, notice that log 6 base 6 to 6 is equal to 1, and log base 10 is also equal to 1. So it follows that the answer is going to be a half. So half times 1 is equal to a half. And so if you wrote a half, it's just 1 mark and it's all you needed. But as I said, I'm trying to explain this as we're going along. Right, next one we're going to is 312. So 312, notice we have the square root of 5x on the outside of the bracket. So this is practically distribution property as in grade 8 and 9. The only trick here is that they put the square roots over the terms to try and confuse us. So let's just write this in an exponent way. So if I write this in an exponent way, it's going to be 5x. So all of it in brackets 5x to the power half. I hope you can agree with that. Now if I come back here, notice I have the square root not only over the 5 but over the x also. Therefore the 5x will be all in brackets to the power half, because all of the 5x is under the square root sign. Now inside the bracket, distributive property, we'll have to take the number on the outside and multiply it by the number on the inside. So that will be the same idea. It'll be 45x to the power half. So the power half means square root. Power cubed, power fraction 1 over 3 is the same as a square root, as a cube root. So to the exponent, 1 over 3 is the same as the cube root of the whatever the number is. Okay, so let's go on. So we have 5 times 45. Those are our main numbers. And then we have x squared, right? So x times x is x squared. And we have all of that to the half, right? So making sense of it, 5 times 45 will be 222. It'll be 225 x squared, right? So not 222, but rather 225 x squared. I made a small mistake here. I wrote it 2. Right, so 225 x squared. And then we're going to have the 2. And now we're going to say square root of 5x times 80x. Also the square root of 80x. Multiply those two. So it's like the same thing that I did over here. Okay? So multiplying the numbers, 5 times 80 will give us 400. So it's going to be x times x. X times x is x squared, all under the square root sign. Now we'll have to square root the numbers. And if you square root 225, we'll get 15. And the square root of x squared, obviously the square root there is going to cancel the square. We're going to be left with x. Right, here we're going to have the square root of 400, which will be 20. So don't forget we have the 2 on the outside. Square root of 400 is 20. And the square root of x squared is going to be x. Right? Now 2 times 20 is going to be 40x. So now we have 15x plus 40x. Add those two numbers up, we're going to get 55x. Notice that this is like terms. They are the x family. So 15 plus 40 will give us 55. And it won't be x squared because it's the x family. This is like terms. Right, and as simple as that, we have 55x. Right, going to the next question. 313, we have what we call exponents. And so this exponents is on the same level as grade 10 exponents. Sometimes I think even a little easier. So all you have to do is break everything down to prime numbers. So if you look at here, we have 4. So 4 can be broken down to 2 squared. 8 can be broken down, and even this 8 can be broken down to 2 to the right. So what we have to do is break down to prime numbers. So this is an easy one because all these prime numbers are going to be 2, right? So 4 will become 2 squared and 8 will be 2 to the power 3. Do note I made a mistake. That's not a 3. It is a 2, right? So in the denominator, please change this to a 2. So next thing, we're going to multiply out the exponents. We're going to say 2 times 3n will give us 6n. 2 times minus 2 will give us minus 4. And then 3 times n is 3n, and 3 times minus 3 will give us, and that's where we'll get the exponent. So we'll get 3n minus 9. So 3 times 3 is minus 9, times all of that by 8. Right, next we're going to have 6n minus 4, right? And then we're going to subtract these in the denominator. So for all the exponents that are in the denominator, you have to change the sign to the opposite sign. So do note that this is a plus 3n. It now becomes negative 3n. The minus 9 becomes plus 9. You only do this for the ones in the denominator. Right, notice that this is not a 3 but a 2. So correction, notice the question, it was a 2. I wrote 3. So looking at these, that's 3n plus 2. It will become minus 3n minus 2. Right, so now we have 2 to the 6n. So now I'm going to put all the n's together, right, as they are, just rearranging it, right? And now we're going to place all the numbers together. Now 6n minus 3n will result in 0 n's. So all these n's are gone. Adding up the numbers, you're going to get 9 minus 2 is 7. 7 minus 4 is 3. So you have 2 to the 3. Right? Don't forget all of that was multiplied by 8. So 8 times 8 is 64. Right, in the next one, we have 3.2. Log 2x minus 5 in brackets plus log 2 equals 1. So the first thing to note is that both these logs don't have a base. And if they don't have a base, this means it's to the base 10. Right? Now, I can write it with the base 10 if I'd like. And so that's what I've done now. So remember, when we have the same bases, right, and there's addition in the center, and we have the same bases, we can write it as one log. So notice here as we can consolidate it, put it together. So here we have log to the base 10 plus log to the base 10. Write it as log to the 10, and where there's a plus, it now becomes multiply. So whatever the numbers are after the log and whatever the numbers are after the log, we multiply them. Okay, and now remember, anything to the log base followed by a number will give you 1. So all I did, I substituted log 10 to the 10 to give me the 1. Now if I have log 10 on both sides, I can drop it and remove the logs. If it's on left hand side and right hand side of the equal to sign, I can remove it and write only the numbers that are left. Now it becomes normal maths like grade 8. Multiply out, right? Normal distributive property. So 2 times 2x will give me 4x. 2 times minus 5 will give me 10, minus 10. And then we have 10 on the right hand side. Moving the minus 10 over, it will become 20 on the right hand side. Bring down the 4x, divide both sides by 4. X is equal to 5. Right, 3.1, we have 27 2 over 3. You can plug this into your calculator and get the answer. Only 1 mark. This is November 2024. So the first thing I would do, if it was more than 1 mark, I would break that 27 into 3 to the power 3 and then write it to the original exponents. Notice that's a denominator of 3 and an exponent of 3. Those two will cancel out. So in other words, it's like saying 3 over 1 times 2 over 3. The answer there is going to be 2. So this will give me 3 to the 2. 3 to the 2 is equal to 9. It's just 1 mark, so you can use your calculator there. Now, 312. This is the question. So that is squaring a binomial. So notice 1 plus root 3 all squared, that is squaring a binomial. You can FOIL it out, write the bracket twice. So write in the bracket twice, FOIL it out using the FOIL method. 1 times 1 is 1. Then 1 times root 3 is going to be 1 root 3. 1 times root 3 again is going to be 1 root 3. Root 3 times root 3 is going to be 3. Minus root 3 root 4. So remember that root 3 times root 4 is equal to root 12. Okay? So now I can simplify this. I'll get root 3 plus root 3 will give me 2 root 3 plus 3 minus root 3, and the square root of 4 is 2. Now I can simplify my numbers. 1 plus 3 is 4. And then I can rearrange the 2 root 3, right? 2 root 3, and notice the 1 at the end here, I can rearrange it as 2 root 3, right? Now those two are going to subtract each other, and I'm left with 4. Okay, I hope that makes sense. So remember, if I have root 3 times 2, it's the same as 2 times root 3. It can swap around. It's like saying 2 times 3 is equal to 3 times 2. It's the same thing. Right, then we got the next paper, log PP. We're still busy on 2024 of the second paper. So log PP. Notice in the previous paper, it was very similar. It had AA, if I'm not mistaken. And then it had to the power half, and you had to bring the half in front. This one is even more simple. So when the base follows a number, what happens? PP, it repeats. What happens? You get an answer of 1, right? Then we're looking at the next one. That's just 1 mark, so you can write the answer in. 314, we have logs. So notice we can break down the 81 to 3 to the power 4. And sine 30 we know is a half on our calculator. And root 5 is 5 to the half, right? Converting it to exponents. So remember, logs is exponents. So you want to convert everything here to exponent form, right? All the numbers, break them down to exponents. So the first one, we know that 81 is 3 to the 4. How do we do this? 3 to the 1, 3 to the 2, 3 to the 3, 3 to the 4 on your calculator. 81. Then sine 30, plug it into our calculator. That's our half. Square root 5, write it as an exponent. 5 to the half. Right, now we can bring those exponents to the front. Notice here that this 4 can go in front. And so if I put it in front, it's 4 log 3, 3. The half can go in front, right? Or can it? No, it can't go in front. Why? That is not an exponent. An exponent will be up there, right? Do note. So I have to write that as an exponent. Who can give me what is 1 over 2? Is 1 over 2 not 2 to the minus 1? Yes. 2 to the minus 1 in your calculator? Half. Right, this is basic grade 8 and 9 maths exponents here we're doing. Right, now bring that half to the front. Okay. And now we have 4 times 1. And then we know that minus 1 is going to come to the front. That minus 1 is going to come to the front. And log 2 is going to be 1, same like how log 3 was 1. Okay, now we got the half that's coming in the front. Log 5 is 1, right? Does it make sense? Right, so 4 times 1 is 4. Minus 1 So minus 1 times 1 is minus 1. With a negative in front, it's going to flip the sign. It's going to become plus 1. You can use your calculator to find it out. Minus a half. So minus a half times 1 is minus a half. All in your calculator. 5 minus a half is 4 and a half. All in your calculator. 5 minus a half is 4 and a half. 3.2, we have 5x plus 2 minus 5x is equal to 24 over 5. So just looking at that, because there's a 5 on the right hand side in the denominator and these 5s, and there's a minus here, my brain already tells me pull out a common factor. So first step is to break that complex one down. 5 and the exponent is x plus 2. So all we have to do is separate it into 2, write it in a different way. So we can see there's a common factor. So writing it in a different way, you agree 5 to the x times 5 to the 2. When the bases are the same, we add the exponents to it. Does it make sense? The bases are the same, the exponents are added. So now we're just going back in reverse, right? We're doing the reverse thing. Does it make sense? So 5 to the x, 5 to the 2. Simple like that. Bring down the minus 5x, right, is equal to 24 times 5 to the minus 1. Now remember that that 5 in the denominator is actually 5 to the minus 1 because it's 1 over 5. 1 over 5 is 5 to the minus 1, right? Now, can you see we have a common factor on the left hand side? That is 5 to the power x. So bringing it out, open brackets, I'll get 5 squared. If I multiply 5 to the x times 5 squared, notice I'll get exactly that again. Which means if I took away the 5 to the x, what do I leave behind? I have to leave something there. That'll be 1. Okay, so 5 to the x times minus 1 will give me minus 5 to the x. Does it make sense? Equals to. Right? Are we good? Now, let's see in the bracket if we can add up those two numbers. Notice we have 5 squared is 25. 25 minus 1 is 24. How easy is this? Divide both sides by 24. You're going to have the answer already. X is equal to minus 1. Right? So when the bases are the same, we equate the exponents. There's our next step. And there we have x is equal to minus 1. As simple as that. Right, 3.3. We have z to the 1 is equal to a half times z2. So, sorry, not z to the 1, so z1, z subscript 1 equals half times z subscript 2 equals to z2 equals that. So do you notice that this question is kind of weird because they want you to take all of this on this side here, z2, take z2 and put it there where z2 is. So in other words, the first step is like a substitution step. Easy marks. So substitute that, okay, and that's what we're gonna get. So where we saw z2, we placed z2 over there where z2 is. Does it make sense? Now we're gonna multiply it out, distribution property as normal. So half times minus 2 is minus 1. So minus 1 times I is minus I. Then we're gonna say a half times 2 using your calculator. Half times 2 will give me 1. Right, and that's our answer, but we have to write it in a way that is the a plus bi style of format. Okay, so that's how it's normally written, right? A plus bi. So don't forget that a half times 2 gave me that 1. In case you're asking, where did you get that 1 from? A half times 2 is 1. Right, now z1 is equal to a plus bi. That's the standard form. So now I need to arrange that so that the I is at the back. Okay, so rearranging that, I'll get plus 1, positive 1, and there's minus I. The next question wants you to calculate the conjugate, or determine rather the conjugate. So the conjugate is denoted with this little line on top. So z1 with the little line on top like that. And that means the conjugate. Now remember, the conjugate will only flip the sign of the imaginary number, not the real number. So the first one is the real number, and the second one is imaginary. So that I stands for the imaginary number. So writing that, we'll get 1 plus I. Okay, notice it was a minus I. Why did I change it to plus I? Because it's not Z1 now that they want. They want the conjugate of Z1, which means I must change the sign that's in front of I. It was a negative I, it's now a positive I. Does that make sense? Now the question says I must draw this on the Argand diagram. Now the Argand diagram is the Cartesian plane. It's the same thing. Right, and notice there's our Cartesian plane. We got X and Y. It's exactly the same thing. The negatives are on the left, the positives are on the right. Negative on the left, positive on the right. Negative is below the line, positive above the line. The y-axis is still the y-axis, and the x-axis is still the x-axis. The only thing to remember is that the a value is plotted on the x-axis, and the y value, which is the imaginary number, is plotted on the y-axis. Right, in other words, the y is the imaginary and the x is the real. Simple like that. Just remember, imaginary is looking up. Okay, imaginary is looking up. So if you're standing on the ground and you look up, imaginary. Okay, you understand it? Imaginary. And that's how we're going to remember where imaginary is. Look up, imaginary. Right, and there we go. Right, so notice that in front of the I is a 1. In front of the I. This means my coordinate, right? My AB value, coordinate, is going to be 1 and 1. This is a very easy example. I can't believe this is in an exam. Okay, 1 and 1. So let's plot that 1 and 1. So A plus BI, this means clearly that the A is 1 and the B is 1. So A is the X value and B is the Y value. Plotting that, moving 1 unit away from the center, right, and moving 1 unit up, we are going to have a dot there. So in other words, A is 1 and B is 1. There's it there, quadrant 1. Join a line from the center and drop it down to the x-axis, and now we got the coordinates 1 and 1. This means I can calculate the hypotenuse. The hypotenuse is what we call the longer side of the triangle, right? So now we have to write this in what they call polar form. So polar form is normally the radius first, right, followed by the angle. So how it's written, radius followed by the angle. That is polar form, right? So going to polar form, we're going to have to find r. So r is equal to, using Pythagoras, it's going to be 1 squared plus 1 squared. Don't forget 1 squared is not 2, but rather 1. 1 times 1 is 1. So that's going to give us r is equal to the square root of 2. Does it make sense? Also special angles, 1, 1, and 2. So that's something we should know, right? So we're going to write this in polar form. So the next thing of polar form we need to find is the angle, right? So don't forget we're working on 333's example at the moment. And then 333 was to draw the diagram. And now 334 is to find the angle. So the angle is equal to tan minus 1, the B value over the A value, and this will give us the angle, right? So remember, tan minus 1 means we're calculating the angle. So theta equals tan minus 1, 1 over 1. We're going to get 45 degrees in quadrant 1. There's our 45 degrees in quadrant 1. So this is quadrant 1, that's quadrant 2, quadrant 3, and quadrant 4 on the Cartesian plane / Argand diagram. Right, so now we're going to write it in polar form, which is 334's question. We found the angle, we have the r, we can write it in polar form. And in polar form, we write it like this. So notice that Z1 is equal to, that's polar form. So we take the r followed by the angle, and that's the way to write it, right? And we get 1,41 45 degrees. But the question said not to work out what's the value in quadrant 1. It wanted us to find the conjugate, right? You with me, the conjugate. So here we found the conjugate here in quadrant 1. right? They said draw it, we did the conjugate. But if you read the question nicely, it's asking you for Z1. Okay, so they say write Z1 in polar form. So now we wrote this quadrant 1 in polar form. You with me? Now we're going to write the other one in quadrant form. So now in polar form. So let's go here quickly. Don't forget that the first part of the question was Z1 is equal to 1 minus I. We are going to draw that now on the Cartesian plane, the Argand diagram. Alright, so there's minus 1, we know. On the left hand side, x, minus 1 coming down also. Tell me, where will this minus I be? Will it be left or will it be down? Think about it. Where will it be? It will be coming down. You agree? Because it's the y. The imaginary is the y value. And the x is moving positively, so it's to the right. So notice that 1 there in front means x is a positive 1. And that minus 1i there means it's a minus 1. There's our dot there. Boop. And there we have it from the center to the point and drop it back to the x-axis. And that's the coordinates 1 and minus 1. Now the question in 334 says write that answer above, right? Which is this one here, Z1. They want you to write that one in polar form. Okay, so this one in that we did here was writing quadrant 1 in polar form. Right, so in polar form, we're going to find the angle. So quadrant 1 angle was 45 degrees. So 360 minus 45, you agree this quadrant here is 360 minus theta. So 360 minus 45 will give me 315. And notice that the radius is going to be exactly the same as what it was before. Same radius. So the radius here is root 2. So root 2, which is the same as 1,41, and there's my angle 315 degrees. It's exactly the same. And so that was our answer there. Right.